Hi everyone, thanks for joining us today for this session. This class will be about railway maintenance processes automation and how to link BIM data to GIS model. Hi everyone, my name is Béranger Marquez. I'm working at SNCF Réseau, the owner of French Rail Network. I've been graduated 1 year ago from an engineering school in Paris through apprenticeships, and then I became an entrepreneur due to an internal partnership between my company and Pathfinder.
My name is Quentin Marquette and I am a former employee of Autodesk EMEA. I met Béranger several months ago in an engineering school in Paris, and I started this project with the consulting division. Béranger and I are coming from the same SNCF training center in Paris-Nanterre, one of the most reputed in Europe. During this class, we will try to provide the best of our expertise, not only about IT or technology knowledge, but also linking with technical permanent wave value for maintenance teams. I wish you will enjoy it and do not hesitate to ask a question using the form available at the end of the movie. Thank you.
Please notice that a full detailed handout is provided to help you follow this conference. We invite you to use it and check each topic referring to these slides. SNCF Réseau is a service provider whose function is to manage railway infrastructure in France. The company has to maintain the network, to build new railway lines, and also to manage the train traffic. To give some numbers so you can get the scale of the company, SNCF Réseau represents more than 15,000 passengers per day in 13,000 kilometers of line. It represents more than 1,600 work sites each year and 250,000 tons of merchandise per day. So what was the problem we wanted to get rid of? To keep it simple, the maintenance manager teams have at their disposal a whole set of tools that are no longer adapted to them. The workflow is non-optimal, resulting in a tedious data consultation. This tediousness is a break in the well monitoring of the area and the well organization of the worksites. The main goal is to limit the data consultation time in order to ease the maintenance monitoring and the site organization. After surveying maintenance manager and technician all over the country, several problems have been highlighted, especially in the data side of the jobs. As we can see in this graphic, the survey highlighted 3 subjects. The goal was to know how much our team were comfortable with the documentation, the tools, and the database. As we can see, regardless of the subject, whether it is database, tools, or the documentation, about a half think that they're not at ease, and about a quarter to a third think that it is tricky. However, one of the major issues will be the following. The time needed to get accustomed to the tools for a manager or technician can climb up to 6 months for 25% of them. Another 25% take more than a year to get used to it. To give you some perspectives, a manager or a technician usually stay only 3 years in a job position. So the main question that stood in our mind during the whole project was how to centralize data in a single location without losing readability or information. So, regardless of the technology involved in the project we would like to make, the concept has to answer 4 main criteria. The first one is to give a visual representation of the area at scale, with important information with visual cues. For example, it is necessary to see the area access for the manager, or also where are the train platforms, etc., etc. We also wanted to have a clear vision of all the constituents, what the railway is made of. The third point is to have a sight over every defect in the area. They have to be geolocalized with a vision of the characteristic and the intervention time limits. The fourth one is actually to find a way to lead intuitively to the desired documentation by filtering the information through to model. In example, if you click on a rail, you'll get access to the rail-related documentation. Alright then, to introduce the project, let's now see the commercial video we've made for our BIM-Door participation.
SNCF Réseau has a subsidiary dedicated to capture the reality using LiDAR aerial surveys. Patrick Jeantet, the former chairman of SNCF Réseau, launched the company in January 2017. Altametris is the name of this subsidiary and was also created to complete the first step towards drones utilization. The main mission of drones are to help SNCF agents to carry out infrastructure inspections, acquire data from the field such as in train stations, and also from general surveillance, called SUGE. SNCF Réseau is also scanning the national rail network by train captures and static laser scanners. The point clouds used for this project were downloaded from the dedicated internal portal and are updated each 6 months. Model authoring process was completed using the Autodesk Architecture, Engineering and Construction collection. We used especially Civil 3D, Dynamo for Civil 3D, ReCap Pro and InfraWorks. The design phase covers multiple trades. The customer scope is focused about a principal set of tracks composed of 8 corridors, but also train station, canopies, 2 underground structures and a maintenance building. Then the client decided also to model the east and west auxiliaries set of tracks to have an overview of the site. One important issue is to take in consideration a huge number of turnouts. For this, we used the rail module available since the 19.1 release of Civil 3D. So, talking about Civil 3D model authoring process, we have two approaches: traditional design process, simplified layout process. We will detail the first one here. Step number 1. Civil 3D alignment are designed for representing the initial single line of a linear feature. It is a 2D component without elevation. The lines, arcs, and spirals that make up an alignment have the ability to interact with one another. This enables you to edit part of the alignment and have the other parts fix themselves automatically. Step number 2. Now that alignment has been established, surface vertical profiles allow you to show a slice through the ground along a specific alignment. This provides a clear and direct visualization of changes in terrain. So, you can assess existing conditions and improve your design if necessary. If the current state of this path is not suitable for driving, you must transform it with more subtle geometry. A new profile, here in red, or a named design profile must be designed. It is also a 2D component. Step number 3. An assembly is a representation of the cross-sectional geometry of the feature you are designing. The parts of an assembly are named subassemblies. They are dynamically linked to one another and affect one another. If you are using an alignment and not a feature line, you can apply super elevation or count on the rail or road project. Assemblies and subassemblies are also 2D components. Step number 4. A corridor consists of multiple individual Civil 3D objects dynamically linked to one another. It combines the alignment, profile forms, and assembly in a kind of 3D chain. Because this 3D chain is dynamically linked to alignment, profile, and assemblies, a change to one will automatically update the corridor shape. Traditionally, when you are designing a corridor, all assemblies are based on the same stations, abscissas. SNCF Réseau has another expectation for their maintenance business and asks us to allow different regions per component, different stations for rail, ballast, and sleepers. So we need to use several baselines in the same corridor definition, one for each component. It is a more heavier behavior, but we can automatize it. Underground structures are also completed with the same traditional design approach. Unfortunately, we do not have dedicated survey plans and the service provider do not completed a LiDAR static scan. Do not forget that underground structures could be an important trade for passenger stations, especially in a highly urbanized city like Paris. Reality capture or topographic surveys are more complex and require a particular expertise, especially when you must rely on previous points as contractors can do for tunnels in Grand Paris Express project. Here we just fix some hypotheses because the civil engineering part is not the top priority for the rail maintenance teams, but this topic is important for federated model and synthèse phase. Autodesk Civil 3D also allows another model authoring process without an alignment and profile line. The 3D baseline is normally the merger of these two entities, but you can also ask to Civil 3D to use the feature line directly as a baseline for corridor creation. It is a more quicker solution, but you cannot calculate count or super elevation with this. Please notice, you must have at least the 17 release of Autodesk Civil 3D to use this function. Step number 1. To start, you need to convert a standard polyline in a feature line object. Please use a 3D polyline directly if you have it, and avoid a 2D CAD object. You can define a name for the feature line, a style, a dedicated layer, and insert it in a site. For this project, we created the feature line by using 2D center lines dropped on the existing ground thin surfaces. Step number 2. Feature lines are smart objects. You can use an editor to change the grades, the stations, etc. Please do not confuse these initial feature lines with project feature lines extracted from the corridor. It is not the same thing. Step number 3. Assemblies and sub-assemblies used are the same as before. But here you cannot use the super elevation or count calculation. Step number 4. Corridors based on feature lines are created with the same dialog box than traditional corridors. You must just indicate you will use directly a feature line and not a baseline referencing to an alignment and a vertical profile line. These corridors can be assigned to a site. For each auxiliary set of tracks, east and west, we defined multiple feature lines in each corridor. For train station platforms, we used a customized Picatinny with target mapping to follow LiDAR aerial survey and deck feature lines. We defined a convention. Feature lines must be in the direction from Paris to region. Be careful to the initial 3D polyline direction before convert it as feature line. Invert it if necessary. After, for each train station platforms, we decided to use the left feature line, still using the Paris to region direction, to recreate the corridor. With Subassembly Composer, we define several elevation targets, but we do not use all for the target mapping for this project. The next step could be to take in consideration geotechnic surveys to adapt the foundations. Canopies are based on the previous station platform corridors. We must export before the top surfaces of the platforms before creating canopies corridor. The Picatinny subassembly is centering as best as possible the superstructure and follows the elevation of the platform project in surfaces. Bridges are created using the grade preliminary function of InfraWorks. During the project, we use the 2020 release of Autodesk Civil 3D, and the new bridge category available with the 2021 release was not available yet. We recreated 3 bridges in InfraWorks based on the point clouds elevation. Then we exported it to Civil 3D through an IMX export. Bridge design was not really part of our business, so we kept it as single 3D solids. The bridge components are default libraries of InfraWorks, but we could also customize it with Inventor. Unfortunately, for the maintenance building and the 2 passenger buildings, Revit models were not forwarded by the architect. So we decided to extrude only the initial plan survey polylines, but why not in the next future try to have the original models. A data shortcut is a link to a Civil 3D object between drawings through the use of XML files. Before, it was only limited to local network, but you can now also use it on the cloud with a BIM 360 Design subscription. Data shortcuts enable users to work in other drawings and share Civil 3D objects, or to explode the design process in multiple files. We decided to use it to simplify the model drawing phase, splitting horizontal and vertical geometry in one drawing, corridors in another drawing, and thin surfaces in another drawing, and so on and so on. Just a quick remark about data shortcut when you are, for example, a service provider without cloud utilization with BIM 360 and when you must deliver to the customer. Think to zip all the design local folder. You don't absolutely not break any link, because if you do this, it's so time consuming to redefine it, so please pay attention. We had two kinds of input data, CAD layouts and point clouds. Remember the context. It is a proof of concept and a mission provided by Autodesk Consulting. We have very few hours available to complete the job, and we must show to the customer the technical pertinence of the context. It was impossible to use point clouds to extract break lines. Too many times, time consuming. We cannot spend 2 full weeks or 3 weeks for this. We chose the quickest solution. Use CAD land surveying plan. SNCF Réseau has standard template for this, because they are subcontracting the operation to external office. On site, the land surveyor is often using a total robotic station. I will explain after why we get some issues for this project. The projected system is RGF 93, New Lambert Zone 44. Just a very quick resume about a French projection system. We can use a global projection system named Lambert 93 for all the country. It is often used by national company for global inventory of assets, but we have a lack of accuracy for large infrastructure. So that's why we splitted also the map in smaller areas named New Lambert Zone. In Paris region, we are using the CC49 projection system. It allows a best accuracy when working locally, and it's also mandatory by the law and asked for each new offer tenders. First, we had to identify the different CAD layer in the DWG template and isolate point for each layer. Unfortunately, we had some surprises regarding the quality of the input file. Each point in the drawing are CAD points. You can say, oh, but you can convert it as COGO points. Yes, sure. But points are in 2D without elevation, and the text labels are not centered on the point insertion. These text labels are also in 2D, so it's impossible to base the thin surfaces on it. We found a temporary solution, but we are not satisfied about the constructor accuracy. We created a blank thin surfaces because the ribbon allows to launch a function moving the text labels to the linked elevation. Autodesk Civil 3D reads the label content and apply it in Z coordinate. After, we had to use a Lisp, allowing to center the text label on the nearest point and try to correct as possible the plan accuracy. But it's not a magic tool. You can find the web link to this routine on the bottom right corner. Despite all the effort, we still have a degraded existing ground thin surfaces. It is not really important for the main set of tracks because we will correct it with the project profile line and the vertical view. But it's more complicated for the two auxiliaries set of tracks because we will base corridor on feature lines. And these feature lines will be created by dropping CAD polylines on the thin surfaces. As you can see on the right, we had tried to smooth the gradients using FeatureLines editor. It was a lack of time. For future projects, if you have this kind of issue with kite data, use InfraWorks to try to generate the EDG in surfaces from the point cloud directly. Bring it after in Civil 3D with an IMX export and refine the local area by kite points or verified polylines. Another important topic for permanent wave studies is the CAN calculation. When you convert a CAD object as an alignment, you cannot start the CAN calculation if the alignment is not detailed with lines, spirals, and curves. I think we can say CAD input data is a nightmare for design engineers. You must recreate the full track layout alignment with the correct geometry. Sometimes it is a little bit tricky because you do not have all horizontal details in archive paper, or maybe your company do not have it. Moreover, the best fit alignment function of Civil 3D is sometimes giving correct proposition and sometimes not.
To this day, every SNCF database is pretty much tied to one type of data, which explains the multiplicity of the bases and the tool at the team disposal. The Excel spreadsheets that you can see on the right of the screen are extracted thanks to the use of robots. These robots allows us to process the data so that we can reuse it with Dynamo for Civil 3D. DefRail is about a rail defect. A rail defect is something that can lead to metal tearing or rail rupture. Each defect is classified following several criteria, such as the localization of the defect, whether it is geographical or where is the defect in the rail itself, the type of defect, the gravity, etc. etc. The defect database can filter by permanent wave areas, allowing to find data more easily. The native spreadsheet exports as Rath layouts. That's why we use robots to convert, standardize layout, and automate the ad hoc process. The objectives of rail monitoring are to minimize the occurrence of events reducing the passenger safety level and or affecting the rolling stock traffic regularity. It also allows us to visualize the state of permanent way assets in order to make the best decisions among the different options offered by the maintenance policy. Geovoix is geometry related. The geometry is the set of characteristics such as the inclination of the railway, the leveling, etc. etc. The geometric defects are classified with the same philosophy as the rail defect, meaning that they are classified related to their location, their type, their gravity, and their intervention time limits. All defects in track geometry are listed in the document accessible online. All data can be exported simply as an Excel spreadsheet without additional development. AD is referring to the dilatation joints. Dilatation joints can be installed for several reasons, such as the need of taking over the dilatation of a rail or the dilatation of a structure. This database is actually taken from a much bigger one. Initially, the data was not intended to be incorporated in the digital model, but things have changed to put the concept forward. Expansion joints are rarely moved or renewed on site. The data does not have the same codification following geographical districts, though the aim was to spotlight critical data to bring feedback and use robots in the future to define and automate the adopted simplified database layout. JIC is about glued insulated joints. These joints have the function of stopping the electric continuity without altering the mechanic continuity. A little backstory for this base. It is interesting to notice that the information for these joints were not intended to appear in the final model, but this was a request for the area team itself. The joint census was just finished, and it was interesting for us to try to implement a use case desired by the team itself. Plus, joint census is not a reality for every area, and thus the way they appear from one area to another is not formalized yet. So it is a great way to try to push the work of an area to try to find if maybe it can lead to a uniform way to resense glued insulated joints all over the territory. The aim with the glued insulated joints is to spotlight the possibility to include additional local data in the process, even if it's not necessarily included in national database. District and permanent way areas could differ a lot following the geographical region, so aligning these topics can only improve trackability and monitoring itinerary scalability. ADV is about the turnout. A turnout is an installation that allows a train to get from a track to another one, or just to cross another track. The main goal of the turnout information implementation, in addition to the obvious important aspect of this installation, was to see the large density of data was not eating the information readability. So just like the previous one, this database is also coming from a more complex database. Ad hoc spreadsheet layout was thought for this proof of concept requirement, so in the future, Rebot will define and automate the adapted simplified database layout. And the last one is armement. It is related to the railway compilation, meaning it is something about the rail type, the slippers type, and also the ballast. The ballast is the material ensuring the transmission and the distribution of the strength applied by the rolling stock on the track subgrade. It's allowed to dampen vibration, permit drainage, and also anchoring slippers following longitudinal and cross-section side. Heavy mechanical packing is used to correct the track geometry on site. There is enough height materials. The ballast is an essential component, and the ballast section to implement must be checked to ensure the track sustainability. Rails are laid on timber or concrete sleepers. Concrete sleepers have longer sustainability than timber sleepers, and their heavier weight ensure better track stability. The rail is what must support the rolling stock trench and ensuring the wagon guidance. The vinyl section profile is the only one still manufactured for the French rail network. The profile is very easy to roll due to its symmetrical and balanced shape. It is characterized by an enlarged base of rail which allows an efficient fastening on the sleepers. To transcribe the overall information visually, an object library has been prepared. You can see the model on the right. Point of interest, POIs, are used for expansion joints, rail defects, and defects in track geometry. These single landmarks were originally designed with Autodesk Fusion 360 for embankment corridors and breaker radar project with Mark Sheedham. The exported block references in DWG was reused, modifying the scale to match for this project and make it correctly visible in the model. The POIs for glued insulating joints was completed with Inventor Professional. A rail sketch is inserted first, then the two extrudable devices on either side are designed, and we include signal log to improve visualization. The point of interest for the turnout is the merging between an Inventor parametric structure and a miniature Autodesk Civil 3D corridor. The semantic display was chosen to make the point of interest as visible as possible. So two types of sleepers were modeled. The first one is a timber sleepers, so the timber sleepers model drawing was completed with Autodesk Inventor. And the second one is the concrete sleepers, so there are actually AutoCAD block references used by Paulo Serra for the promotion of the Dynamo for Civil tool in 2019. So on one end we use Autodesk Civil 3D to define multiple property sets, so you can see the number of attributes depending on the POIs. On the other hand, we use Dynamo for Autodesk Civil 3D to fill the data in the property sets fields, so for the point of interest this is a multi-track script, but for the sleepers, the rail section and the ballast section this is a one script per corridor. So as you understand, the idea is to collect our database information in order to place them in the right place. Dynamo reads and recovers information from our Excel spreadsheet, then combine the information with the model generation insight. The modification can be things like converting kilometer to meter or more complex one. The next step is to isolate information referring to each track to then transcribe them on the Civil 3D alignment. Once Dynamo has interpreted the data to transcribe them into Civil 3D, it is now possible to place a POI at their emplacement and to integrate the set of data desired into them. So, now that the model is created, we use Navisworks to visualize the model overall. The software allows us to aggregate the different sources of data, to consult the data from the database, so as you can see in the picture on the right, to effect hypertext links that allows us to get to the business application really quick, and also to lead the users to a set of documentation relative to the object that they've clicked on, and also to export the model at a t-time, which could always be useful in terms of archiving. So as briefly mentioned in this presentation, one of the most important points for a proximity manager is the internal corporate workforce turnover. Manager and technician are only allowed to stay 3 years at the same geographical job position. Each 3 years, another employee is coming to fill the position. It's time to be comfortable with the internal tool can reach up to 12 months. Monitoring staff criticism is that the human workforce is not at its full potential and over a substantial part of the job position duration. It must be found a way to smooth the HR turnover and relieve the end of a knowledge process. These improvements are essential to make easier and to optimize the employee working time. Another important point is to limit the time required for data consulting and to schedule maintenance tasks. Proximity manager must spend more time on site with the teams. This job is one of the first positions in management working. Employees must develop their technical skills because the opportunity still allows it. This expertise will follow them during all their career path, and this first position consolidates the knowledge base. It seems logical that spending less time to schedule and monitor processes allows to spend more time for the staff management. It should necessarily lead to a more qualitative team management and therefore increasing skills for agent and district division. This set of improvements must therefore benefit to monitor the network sustainability.
Autodesk Civil 3D and ArcGIS Pro do not have exactly the same behavior. Autodesk Civil 3D is based on an AutoCAD engine. AutoCAD is just using a CAD geometric element such as lines, polylines, circles, spline, hatch, etc. Users must have at least an AutoCAD Map 3D to bring added value. Only the Map 3D engine is able to use object data, for example, also named OD. Civil 3D model authoring use improve object via smart component. In our case, output data is composed of 3D solids exported from corridor designs, or also block reference implemented with Dynamo. ArcGIS Pro use map features, only points, lines, or polygons for 2D GIS. But with the new 3D GIS, ArcGIS Pro use multi-patch feature class for volumetric entities. So it is a little bit difficult to link each component from CAD and GIS. Despite the partnership between the two software corporations, the Autodesk connector for ArcGIS do not allow to export directly linear design. And also, when we worked on the project, the 2.6 release of ArcGIS Pro was not still available. Now, the new release allows to read directly DWG file, but not to understand correctly each component, and we will talk about it in the next slides. When you do not have a native connection between BIM and GIS for linear design, it is more difficult. It seems more complex, but it is not impossible to achieve it. We used an ETL named FME. FME is the acronym of Feature Manipulation Engine and is released by Ceph Software, a Canadian company. Maybe some of you know the product as data interoperability for ArcGIS. An ETL is a tool allowing to extract, transform, and load data. Some of geospatial ETL allows to transcribe DWG files to geodatabase file format, also named .gdb. Of course, we are keeping the geometry and all the data implemented in the Civil 3D property sets. Data is transcribed in 3D GIS attribute tables following an information mapping. Several applications are included in FME Desktop Suite. Please notice that it is available for Windows operating system, but also for macOS and Linux. FME Workbench is a visual programming tool allowing to use transformers. It is the most important app. FME Data Inspector is a visualization tool. For example, FME is able to open a viewer with your DWG input files. FME Quick Translator is a simple converter. Maybe some of you already use it with InfraWorks when you try to import CTGML input file. FME.exe is software accessible as command line. We do not use it. Safe Software releases also server and cloud services. For example, if you have a lot of files, you can treat it online with batch processes. You will find enclosed an example of visual programming function with FME. Scripts are using .fmw file format. On the left, I define my input data, in fact, each CAD layer. On the right, I include all the writer to export a geodatabase file format. For this case, we just use the transformer allowing to keep the geometry. To transcribe the data, it is a little more complex and you need to use additional transformers also. When you will insert the geodatabase feature classes in the ArcGIS Pro project, you want to stylize it after. That is why you must think to your future GIS utilization when you are completing the model authoring process with Civil 3D. It is crucial to have correct interrelationship between CAD and GIS layer. For example, during this project, I forgot to split concrete slipper and timber slippers in several CAD layers. I had both types in the same Civil 3D layer, and when I searched to stylize timber slippers in brown in ArcGIS Pro, my concrete slippers were also in brown. But in the real life, of course, concrete must be in gray, not in brown. So just one advice, when you are preparing to use your Civil 3D input data with FME, just check before to have classified each CAD layer. So you will find some screenshot enclosed below. You can check when we succeed to transcribe the Civil 3D property set as GIS attribute tables. Now we will be able to use all the power of Esri ecosystem to complete geospatial analysis and also more with ArcGIS Online. ArcGIS Pro 2.6 was released in July 2020. Before, it was not possible to bring directly a DWG file with 3D component. The new update allows to drag and drop directly a CAD file in the project or use a BIM 360 connection to insert a drawing in the ArcGIS Pro project. About geometry, the software is filtering CAD component and class it by nature in different groups. Group number 1, points, including CAD points and GoGo points. Points group for only GoGo points. Polylines, including CAD lines, CAD polylines, and also CAD splines, polygons, multipatch for 3D solids, annotations, annotations groups, it's for Civil 3D object, but it's also recognize pipes for Civil 3D object, alignments, alignment profiles, but also sites, still for Civil 3D object, parcels, feature lines, and feature lines groups. About thin surfaces coming from Civil 3D, now ArcGIS Pro can use directly to refine the terrain in the project without using FME. Before, we must use the ETL and convert it, the thin surfaces, as a raster with geoprocessing functions. About data, we still do not have Civil 3D property set natively, but it includes now some CAD data per default. For native stylization, the tool do not take in consideration all the CAD colors for the moment. About projection system with DWG file, we still have some issues. For our first test, we succeed to insert DWG in a 2D map and also a local scene, but we noticed some warnings about projection systems. But we have something displaying in the screen. Unfortunately, for global scene configured with WGS84, also known as LL84, we do not succeed to display something. Investigations are still in progress about it. The next expectation for SNCF Réseau is to bring the model on site for the agent. It's difficult to use InfraWorks mobile app with the iPad because the application is not available, and BIM 360 for SNCF is not the default common data environment. So the choice was made to use ArcGIS Online with corporate tablets. Unfortunately, it is not possible to export directly the ArcGIS Pro model to ArcGIS Online. The platform online uses WebGL technology to display the content and need to complete before some processings. We have two kinds of data in our model, point clouds and 3D object. To export it, we need to launch function to convert it as scene layer packages, also named SLPK. Each SLPK file must be uploaded after on ArcGIS Online to rebuild the 3D scene on the cloud. Only after this you can use it from your account panel with a tablet on site.
So now let's make a quick overview of our workflow. So the very first step is to take the last file format and to send it into Recap Pro, so that Recap can actually transform the file into .rcs or RCP. The next step is to send those files into InfraWorks so that we can build the preliminary bridge design. The next step is, once you get your 3D polylines and land surveyor input data in DWG, you can send it into the Civil 3D software so you can build the TIN surface for the model authoring. This surface will be useful for our permanent way, our station platforms, our canopies, subways, and model authoring. There is two kinds of approach. The first one with alignment, vertical profile view, and the subassemblies, and the second one which use feature lines and subassemblies. After that, Dynamo will read the script that we made so that it can implement the information from our Excel spreadsheet to the Civil 3D model. Within our multiple Excel spreadsheet coming from our database, there is two types of information. The first one is leading to the first configuration, which means individual POIs are implemented through a corridor using a standard block references library. And the second type of information is leading to another configuration, which means that the 3D solids are coming from Civil 3D corridors and intrinsically modified with additional property sets. Once all the information are available, Dynamo will read scripts and then implement the POIs as block references or made intrinsic modification of the object structure data. Once it is done, it can add the customized property sets. Then we're going to aggregate the multiple trades into Navisworks. And Navisworks is going to be the software used in agency premises by the manager and the technician so that they can see all their area. Then we're going to use the extract, transform, load software to convert the DWG files into GDB GIS format. Then after that we're going to insert GeoDatabase feature class A3 scene using the geoprocessing utilities and to export the file format in scene layer packages. And finally, for the last step, we're going to use ArcGIS Online so that we can use the WebGL technology using the 3D scene on site with a pad. There is still one step that we might want to go to, but there is still investigation that needs to be made. It is to use the F3 device apps so that we can modify data and the property sets on site.
So the next step is to continue to work with this workflow and integrate other rail traits, OLE, overhead lines and energy, signaling, telecommunication, geotechnics, surroundings and environment. About OLE business, we invite you to watch the class of Jean-François Villette if you are French speaking. Jean-François is based in Nantes in the Regional Engineering Center of SNCF Réseau, and he is also a speaker for this digital edition of Autodesk University. His class is related to the BIM implementation for OLE for the 2 last years and especially about Revit and Navisworks workflow. So, City Dashboard is a web app based on ArcGIS and also a demonstration completed by Gaëtan Lavenu in France during a conference in live in 2017.
ArcGIS is a web GIS platform, which means that it is in its architecture to incorporate new tools, new technology, allowing connection to real-time data flow through API and web services. We can thus report data from on-site sensors, connected objects, social networks, etc. The tool can become a data aggregator, a real dashboard that will govern variety data flows. The layout is visual, in three-dimensional environments, whether in the office premises or on tablet touch screen on-site. All these elements tend toward a monitoring and hypervision solution. Esprit France already started to work about it by making available a dataset named City Dashboard Paris and City Dashboard Grand Lyon. So to push the concept forward, we can add some data flows in the project. We can use the Waze API, which is an API about the road traffic, accident, and fieldwork data. We can use the closed circuit television camera flows, which is for the SNCF surge security teams. We can also add the data flows on self-service bicycle station, data flows from electric vehicle terminals, cultural events flows with the Open Adada API, Twitter publication stream with the Twitter streaming API, data flows from Netatmo weather stations, data flows related to ticketing equipment and information panels, and data flows about the railway traffic.
Esri portfolio includes several mobile apps: Survey 123, Tracker for ArcGIS, Collector for ArcGIS, Explorer for ArcGIS, etc., etc. We are interested by Survey 123 and Tracker for ArcGIS. SNCF is using a lot Kiseo platform to complete forms and surveys on site, and we will try Survey 123 to check the interaction with the ArcGIS Pro project. Tracker for ArcGIS mobile app was before dedicated to an utilization with ArcGIS Enterprise and is now available with a simple ArcGIS Online subscription. It follows the position of agent on site, could be walking or driving, and the app can create an itinerary and export the result as a shapefile. This shapefile could be reused, why not directly with ArcGIS Pro, but also with Autodesk Civil 3D, with a map import function. We could imagine recreate quickly a Civil 3D corridor based on a feature line and a simple subassembly. It could represent a path, or maybe why not a vehicle boundary, or imagine to use it in Navisworks in the future for a potential clash detection, etc. Visualization. So great topic. ArcGIS Pro already allows visualization as a single character and following his point of view. See what over can't. I think Jack Dungerman was true with his slogan. To come back to SNCF, the dream of each signaling engineer is to be able to see the signals when you are driving a train. We would like to investigate with this function and see if with additional development, we will be able to use it as a dynamic visualization in a rolling stock cabin. For example, Deutsche Bahn, the owner of the German network, already started this kind of investigation, but with InfraWorks. During this proof of concept, Béranger used a lot Excel. Power BI is a new tool of Microsoft for data layout and charts. It is so immersive. Unfortunately, we do not have enough time to prepare content with this tool for this project, but it's something we keep in mind for help us in the future for data management. Software implementation is a huge topic for SNCF Réseau. This proof of concept highlighted the possibility to bring back BIM data to GIS attribute tables, but some points are uncompleted. On-site, it's not often possible to have access to cellular networks in 3G or 4G generation, and we really need an offline mode. And why not be able to edit attributes on-site and be able to bring back the modification when we return to the office? It is something we need to investigate. The road to success is very long. Moreover, SNCF is the owner of the asset, and it's important. The solution must be secured in SNCF server and not on the cloud. The company is very focused about the on-premise mode, and IT security is an important check before starting a massive deployment. Something we learned during this proof of concept is the need to have important IT skills. Software are numerous, but so powerful that we already had 10 years ago, for example. It requires also new skills, and especially related to code development, Python, C, C#, and also web technologies, JavaScript, Node.js, etc. And in the AEC business, we have a cruel lack of skills about it. I think it is the case for owners, but also consultancies, engineering company, or contractors. We are engineers, not developers. If SNCF Réseau made the choice to use ArcGIS as an official platform for the digital twin, it would be mandatory, for example, to use ArcGIS Enterprise. Implement the solution is something technically complex, and manage real-time data flows require also GeoEvent server. For the moment, we are not ready to jump directly on these developments. We will reinforce what we already completed during this proof of concept. We will try to give the best of ourselves and continue to investigate all the potential doors we already have.
So the project was a nominee in the Golden Beam Award, which is a ceremony that rewards the best projects in France and overseas. This year there were 11 project categories. The project initially was named in the Operation and/or Maintenance category, but was chosen by the jury for a Silver Award and won in the Infrastructure category.
Hi, I'm Judy Caldeota, Deputy Director of the BIM and Digital Continuity at SNCF Réseau, the French Railways Network Infrastructure Manager company. As part of this program, we are using BIM to accelerate the digitalization of the conception, construction, maintenance, and railway operation as well. Obviously, we are supporting this project presented to you during this IO. This project highlights how BIM can bring value for railway. We are convinced that connecting BIM with our internal database, including GIS, will allow us to improve the monitoring, carrying out our maintenance, and to streamline our internal process. Thank you and enjoy.
So I really would like to thank you for your attention. It's been a real pleasure.
So thank you for your presence and do not hesitate to contact us for any additional information.